So here to talk through this Tapa black hole variation by Zoltán Horváth called blind spots. This is a variation that will also appear in the Tapa Variations 3 book that we're releasing soon. In this case, we're going to have one black hole per row or column. That's with the n of 1, but the m equals 0 is an interest constraint. It means we're going to be able to extend group sizes. Like this 3 would be perfectly valid if this were like this with 2 black holes, because I only have 3 cells here. So it can make groups larger, but it's not going to be able to make full groups any larger. So 1, 2, 2 is already a full clue with a white space around it. So it always has to take these extremes. 1, 1, 3, also a full group. All of these cells can be marked for sure, and one of these remaining ones will have to be shaded, but no black holes around these groups. Also this 1, 5, like over here, looks like it's going to be set. And one thing to note is one of these that gets marked off is going to put our first black hole around this 1, 1, 1 clue. So some different things to think through there. Another thing to note about this grid is it's pretty constrained. It's got 8 choke points, basically these cells I'm marking in here, that in these corners we'll always have to take at least one of them, but we may have to flow through both of them if we have some travel constraints through the corners. So these are key cells to look at. Actually, where we have this 1, 3, this is going to be an example where one of these will be a choke point coming back to maybe these cells or coming back to these cells. And so these influences will matter. And the place I want to first look at that is maybe right over here and ask, can I actually have this be off and allow for one of these shadings to work with this clue? There's a case where this would be the 3, and if this is the 3, this extends over here, but how do we make this be a 1, 3 clue? Even with black holes, we can't reach and form a second shaded group around it. And if it's not used, we'd still have to come around, but for connectivity, we come through here. And so there's a challenge of keeping the whole space connected if this is constrained off. It basically requires this cell to come around through the space, but this 1, 3 clue wants one disconnection here. It sort of wants this pattern or this pattern, and however that ends up working, I guess how I'm drawing this now needs a black hole. That disconnection doesn't allow a choke point here. Instead, what this is saying at the start is really both of these want to be on, and marking that in actually marks these off, marks these in, marks these off. We're going to have this group coming down, and this could potentially have a black hole, so I'm not going to mark anything else off for that 3. But for sure we've got this group coming up for this 1. And what's interesting over here is we've got a 1, 2 clue. We've already used 2 cells, but we need to take one more for us to be connected. So this is going to be the first place we know there's actually a black hole for sure. It's going to be in one of these 3 cells, but actually with this 1, 2, 2 clue being fulfilled, it's not in the cell. It's either just in the top cell or the right cell. So I'm just marking that there's something around the space, but it actually just has 2 cells that are valid in that set. With this marked off, this choke point's marked in, this marked off, this marked in. So we got some starts from doing that. We're going to have, let's maybe work on this lower left corner first. We've got to get around this 2 clue, and we still have to get up to the space. And this would take 5 cells, but only 2 can be in a black hole. That would be 3 shaded for sure. So we've got to take this cornering. That means that one of these cells has to be a black hole because of the 1, 1, 1. With this cell also now shaded in, this has to be shaded off because you can't get 4 in a row with 2 black holes, too many. So this comes over, and we actually have now 4 cells shaded. What does that mean? We need a second black hole here. And the only way that works is in another row. So this pushing this over, actually then pushing a black hole here, looks like it's absolutely required at this stage of the puzzle. All the rest of these cells are marked off. This is marked in. So this is the 2 of the 1, 1, 2. This will be the start of the 1, 1 parts. This comes up and connects. This is needing to come up to connect, so it's actually now creating another cell that's going to be a black hole. One of these 2 is a black hole, but notice it can't be this lower one because around the 1, 1, 2 this counts as a 1. So this is a black hole. For connectivity, you have to come through the center, and this being shaded actually means all of these around this 5 get shaded. So this needs to have 2 black holes, one of which we've marked. Another is going to be in here, and notice around this 1, 4, this 1, 4 now actually has 5 cells, it looks like marked. These 2 are for sure shaded because they're around this 1, 2, 2 clue, which is good. So the other black hole is in one of these cells, specifically the bottommost or the topmost in the set. But we now have a good set to get this 5 to work out. Put this in to shade through in the space. We have to mark this off and this in for the 1-4 to work out. And with all these black holes in the bottom row, we actually now know for sure that these are all off. We've got to work on this 1-2 on the side. If I took this cell, well, I guess for sure I always has this cell. If I took this cell, I can't take either of these, and that isolates part of the grid. So instead, this is on the top. This takes this cell. Notice if I take this, or if I take this, these cells on the right have to get out. So I do want to think a bit about that connection. And this isn't a good route to get out, but this looks fine to come up this way. This 1-4, the 4 can come like this and maybe take even more cells. The 4 can come like this and take to this cell. So this cell is always shaded. That finishes this 1-5. It puts in this cell, which now requires another black hole. That black hole is limiting that 6 to now just have 2 things shaded. So it comes all the way to here. It looks like 7, but counts as 6. Again, for connectivity, we need to take 1 more for this to work. So that comes in, this comes in. Those all look good. Guess the next thing to think about a bit is this 1-1-2 and stuff that might mean in terms of shaded cells. One side could be this be 1-1 and then this side be the 2. The other is this side is the 1-1. In both of those, this gets shaded. So I'm going to start with this being shaded, recognizing I'm near a 2-3. I got to shade this cell. Question is, this can connect this way and actually has to connect that way. So this comes with 4 now in a row. So this is actually another place. There's going to be a black hole in one of these 3 cells. For sure, the 2 is now complete on the left. This is for connectivity. Still have some different options for this. But one thing it's starting to force is an interesting shape around this 5 clue. And something else I'm seeing is I may be able to force 1 more cell in this 5 clue, which is this one. And that's from looking again back at the 4. So one form of the 4 is like this with the black hole. The other is if this comes in and are these 4, notice that there's going to be a black hole around these because of this one here. So this is still at a count of 3, meaning it needs to take this. So I think this is a key one to mark. And it's a key one to mark because it now again means this 5 is going to end up like a 7 pattern. I don't know if it uses the left or right, but for sure these connect. And it needs to have 2 black holes. And because there's a black hole here, it can't have a black hole in these cells. So it needs a black hole in the middle column and the rightmost column. The first thing to note is this one. The rightmost column is going to have to be near the spaces we already said there would be a black hole. And then the last option is going to be this one up top. So these get marked in. Knowing this is a black hole here means we don't yet have a count of anything, so this has to extend further up like this. So this is actually the 1-4 split that puts these in. This now has an either or for a black hole, but this is a good 2 count here, so it's going to have to be the left and the right like these. We can come to some other rows and columns. Like this column doesn't have a black hole yet, but it can't be here, it can't be here, it can't be here because it's already there, it can't be here. This is good around the 1-5, so this has to up here be a black hole. On the far right, these counts are all good, these counts are good. I have just this cell for a black hole, so I have everything marked, it looks like, except for this cell right here. And that means if this is the last black hole, it's both part of the Tapa, but not part of the 7 clues, so coming all the way around the 7 is forced. Marking that off, I now see that I have a good 2 here, which means this is a 1-1. And we finish this grid. So a pretty interesting puzzle. It definitely had you tweak the Tapa logic a lot, but thinking about the choke points in the grid, these 8 cells that isolate all the 4 corners from the middle, those got some key things. We basically had to fill both of these in because the 1-3 is a disconnecting clue. That broke here, which put this in, which broke here, which put this in. These had to rejoin in the center, and so starting to form this 5 shape and then working around the 1-4s really helped us out, particularly seeing that we had to get 2 black holes around this clue to force the last black holes and force the shape of the 1-4 exactly to be this as the 4 and that as the 1. So a good puzzle. Thanks, Zoltán, for writing it. Look forward to seeing the variations book soon, and definitely hope you enjoyed watching this video. We'll catch you soon.